drop a like and do share. Leave your comments and do not forget to subscribe for more videos.
Dear students, let's continue with chapter Organic Chemistry, some basic principles and techniques. So far we have completed all these topics. Now in this video we are going to do some practice problems on qualitative analysis. Okay, the first problem is, on complete combustion 0.246 gram of an organic compound gave 0.198 gram of carbon dioxide and 0.1014 gram of water. Determine the percentage composition of carbon and hydrogen in the compound. Okay, so what we are going to do is, I will provide the rough framework how you have to solve the problem. Then we will pause the video and you can solve the problem, and after that I will provide the solution. Okay, so now what's given is that the weight of the sample. Okay, and we have got weights of carbon dioxide and water. So use the mole concept and find out how much of carbon is there in this much of carbon dioxide and how much of hydrogen is there in this much of water. Okay, and after doing that you can find out the percentage composition of carbon and hydrogen. So pause the video and solve the problem. Okay, so let's see the solution. So first of all you have to find out how much of carbon was there. Okay, so the weight of carbon is 12 and weight of carbon dioxide is 44. Okay, so now you had 0.198 gram of carbon dioxide. Okay, so you can simply do, in 44 grams CO2 we had 12 gram of carbon. So in 1 gram there will be 12 by 44. So in 0.198 gram, how much carbon will be there? 12 divided by 44 into 0.198. So this much is the amount of carbon present in the sample. Okay, so now what will be the percentage? For getting the percentage, divide this number with the amount of organic compound and multiply by 100. That's a simple formula. Okay, so what we have done is, this is this number which we have got, divide that with the weight of the sample and then multiply by 100. So we got final answer 21.95%. Similarly, you can do it for water. Atomic weight of hydrogen is 1 gram. We are doing it for 1 mole. Okay, and then for water it is 18 gram. So in 18 gram of H2O, how much is there? 2 gram of hydrogen. So in 1 gram there will be 2 divided by 9. Similarly, in 0.1014 gram it will be 2 by 9 into 0.1014 gram of hydrogen. So this much is the weight of hydrogen. Okay, now divide this number with the amount of sample and then multiply by 100 to get the result. This is what we have done here. Okay, and finally we got 4.58%. Clear? So let's see the next problem. So next problem is, in Luhmann's method for estimation of nitrogen, 0.3 gram of an organic compound gave 50 ml of nitrogen collected at 300 K Kelvin temperature and 715 mm pressure. Calculate the percentage composition of nitrogen in the compound. Aqueous tension at 300 Kelvin is 55 gram. So how we are going to proceed is, we have the amount of organic compound, we have 50 ml of nitrogen at the given temperature, and pressure, total pressure is 715, but out of that 15 mm is due to water, that is the aqueous tension, so we have to subtract this. So whatever the pressure is due to nitrogen is only 700 mm of pressure. Okay, so you have volume, you have temperature, you have pressure. We can either use ideal gas equation and find out the amount moles, first find out the moles of nitrogen, then you can find out the amount, weight of the nitrogen, and by that you can find out how much is the composition of nitrogen in the sample. Or otherwise you can also do that, you can directly use that relationship, that at STP 1 mole of any compound has 22.4 liter volume, and you can also use that relation, PVT relation, to find out how much of nitrogen was there. Okay, pause the video, try this problem for yourself. Okay, let's see the solution. Okay, so as I have earlier told, what will be the actual pressure, that is 715 minus 15, that will be only 700. Okay, and other facts were given, that temperature is 300 Kelvin, and at that temperature, and this is pressure, how much is the volume was there, 50 ml of volume was there. So now either you can directly use PV ideal gas equation, that is PV is equal to nRT. You have the pressure, you have the volume, okay, you have the temperature, okay, use the constant value of R, then you can easily get N, that is the number of moles. Once you get the number of moles, then you can easily get the amount of nitrogen, and then rest of the thing will be same here. The other method was, like, you have to find out what will be the volume at STP, okay, and then by comparing their relationship, that at STP 24 liters of nitrogen has 1 mole of quantity, so we can use that relationship. So let's use it. So how much of volume at STP will be there? So we can use this relationship, since these two quantity are constant, so we can say P1 V1 by T1 equal to P2 V2 by T2. Okay, so now we have to find that what will be the volume at STP. So we will use the pressure quantities given here, okay, the volume given here and the temperature given here, then the STP pressure and STP temperature. Okay, so just put these values, that is pressure 700. Okay, volume 50 ml. So P1 is done. Then temperature 300 Kelvin. Okay, now take these two quantities on the other side, then you will be left with only volume. Okay, so STP temperature is 273 Kelvin and STP pressure is 180 m or 760 mm of Hg. So since we are using here mm Hg pressure, that's why we have used 760. So final result is 441.9 ml. Okay, this is the volume at STP. Okay, so now we can use that relationship that at STP 1 mole of any quantity has 22.4 liter of volume, that is equivalent to 22,400 ml. Okay, 22.4 liter or 22,400 ml, that has 1 mole of any gas. We have nitrogen here, so 1 mole means 28 gram of nitrogen. Now we have volume 41.9 we have got here. So how much of nitrogen will be there? Simple, in 1 you will have 28 divided by 22400, and similarly in 41.9 will be having 28 divided by 22400 into 41.9. This was the weight. Either you can do the calculation here or just leave it as it is. Then you have to find out the percentage of nitrogen. Just divide this quantity with the amount of sample, that is 0.3, and multiply by 100. So finally you will get 17.46%. Okay, let's see the next question. During estimation of nitrogen present in an organic compound by Kjeldahl's method, the ammonia evolved from 0.5 gram of compound in Kjeldahl's method. Estimation of nitrogen neutralized 10 ml of 1m H2SO4. Find out the percentage of nitrogen in the compound. Okay, now here you have to use the neutralization reaction and find out the amount of ammonia gas involved in the reaction. From there you can find how much of nitrogen was present, and then you can find out the percentage composition. Okay, so try it for yourself. This is the equation which you can use if you don't remember. Okay, let's see the solution. So we have 10 ml of 1m H2SO4. So just find out how much of moles of H2SO4 has been used. So the moles of ammonia used will be twice of that. Okay, once you got the moles of ammonia, then you can find out the moles of nitrogen, from where you can get the amount of nitrogen, and finally you can get the percentage of nitrogen. So you can use it volume wise. So if 1m of 10m H2SO4 is being used, so with the same molarity, if it is 1 volume, then it will be 2 volume. Simple. So since 10 ml of H2SO4 having molarity 1m is being used, so amount of ammonia consumed will be just twice of that. So 1m of 20 ml of ammonia will be used. Okay, and Okay, and in 1m molarity definition is number of moles divided by volume in liters, or I can say 1000 ml. So 1m means 1 mole of the solution we are talking about divided by 1000 ml of the solution. So here we can say that 1m NH3 means 1 mole of NH3 in 1000 ml of solution. Or similarly we can say, since in 1 mole of NH3 we have only 1 nitrogen, you can see, so we can also say that similarly 1 m nitrogen will be there. Okay, so 1 m nitrogen will be there. It will be similar to 1 mole NH3. So 1 mole of nitrogen, that is equivalent to weight of nitrogen is 14 gram. So we can say that how much of nitrogen is there in 1 m NH3 with volume 1000 ml, that will be equal to 1 mole sorry, that will be equal to 14 gram. Okay, so we can write it as 1000 ml of 1 m NH3 has how much of nitrogen, that is equal to 1 mole equal to 14 gram. So it has got 14 gram. Similarly 1 m will have 14 by 1000. So now we have how much of ammonia, that is 20. So in 20 ml how much will be there? 14 divided by 1000 into 20. This much is the amount of nitrogen present in the sample. Okay, just divide that number with the amount of sample, multiply by 100 and you will get the percentage. So final percentage is 56%. Okay, clear? We are just using here the basic techniques of mole concept. If you have any problem, just revise that chapter and these things will be easy. Let's see the next problem. In Carius method of estimation of halogen, 0.15 gram of an organic compound gave 0.12 gram of silver bromide. Find out the percentage of bromine in the compound. So this is pretty straightforward. We have weight of the sample, we have weight of this residue, silver bromide. So in this you can use the mole concept and find out how much of bromine will be there in 0.12 gram of silver bromide. So once you get the amount of bromine, you can easily find the percentage of bromine. So try it for yourself. Let's see the solution. First, what is the molecular mass of AgBr? So silver is 108, bromine is 80, so it will be 188 gram. Okay, so in 188 gram there will be 80 gram of bromine. So in 1 gram it will be 80 divided by 188. So in 0.12 gram it will be 80 divided by 188 into 0.12 gram. So this much is the amount of bromine in the sample. So now we have to find out the percentage composition. So we will divide this amount with the weight of the sample and multiply by 100. So finally we get the answer 34.04%. Okay, this was quite easy. Let's see the next problem. Similar type of problem. In sulfur estimation, 0.157 gram of an organic compound gave 0.4813 gram of barium sulfate. What is the percentage of sulfur in the compound? Same, this much of barium sulfate is given. So now you have to find out how much of sulfur will be there in this much of barium sulfate. Then you can easily find out the percentage. Just try it for yourself. It's similar to the previous problem. Okay, let's see the solution. First of all, the molecular mass of barium sulfate will be equal to, barium is 137, sulfur is 32, oxygen is 16 into 4, that is 64. So total is 233. So 233 gram of barium sulfate will have 32 gram of sulfur. So how much of sulfur will be there in 0.4813 gram of barium sulfate? So it will be 32 divided by 233, okay, into 0.4813 gram. So this much is the amount of sulfur. Now the percentage of sulfur, just divide this quantity with the amount of organic sample and multiply by 100. So we will get the answer as 42.10%. Okay, that's all. Thank you.